Question 14. In the adjacent figure, the sides of the two squares and the diameter of the circle are equal in length. What is the probability that a randomly chosen point on this figure is located in A, the red region, given that this point is located in the blue region? We're randomly picking some point within here, within this object. This length is the same as this length, right? And so what I did, I just broke it down into the radius. So I'm saying, I called this from here to here the radius. This length is going to be 2 times the radius. The area of the green square would be 2 times the radius times 2 times the radius. 2r times 2r is 4r squared. The area of the blue square is also 4r squared. The area of the circle is going to be pi r squared. The area of one of these little tiny quarters of that is going to be a quarter pi r squared, or 0.25 pi r squared. So the area of this little tiny quarter of the circle is 0.25 pi r squared. The area of one of these little squares is just, well, it's just r times r. So this is just going to be r squared. One of these little squares is r squared. The total area of the whole thing is the area of the square of this square, 4r squared, plus 1, 2, 3 of them that we haven't counted yet. The whole blue thing, that's 4r squared plus 1, 2, 3r squared. So that's 7r squared plus this 0.25 pi r squared, right? The quarter of the circle. The quarter of the circle plus 7 of these little squares. 1, 2, 3, 4, 5, 6, 7. And then the quarter of the circle. This is the area of the whole thing, which we could simplify to being like 7.7854, and it goes on forever, r squared. They want to know the probability of picking a point that's inside the red region, given that it is located in the blue region. Right here, this is in both red and blue. This is in red and blue, and it's also in the green, anywhere in here. The probability of red given blue is the probability of red and blue. So what's the only part that's red and blue? Right here. So this is red and blue. That's going to be half your circle, 0.5 pi r squared. 0.5 pi r squared out of the whole thing, out of the 7.7854 r squared, divided by the probability of being blue. Being blue is 4r squared out of 4r squared out of the whole thing, out of the 7.7854 r squared. We're going to divide these two fractions. When we do divide the two fractions, the dividing fraction is going to flip and it's going to multiply it. So we multiply by the reciprocal. So we have 0.5 pi r squared over the 7.7854 r squared times the 7.7854 r squared. So these two things are going to cancel. This one and this one totally cancels. And we're left with 0.5 pi r squared over 4r squared. So 0.5 is a half. The 2 from the half is going to multiply the 4, and we're going to end up with 8. And the r squareds are going to totally cancel. So you're going to have pi over 8. All right? Or you can just work that out on the calculator. The r's totally cancel, so 0.5 pi divided by 4 is going to give us 0.3927, or 39.27%. And that's 14a. For 14b, the green region, given that the point is located in the red region. Very similar. The probability of green given red is the probability of red and green, or green and red, same thing, divided by the probability of red. But the probability of red and green, this region, so half the circle, so 0.5 pi r squared out of the whole area, so 0.5 pi r squared out of the whole area, divided by the probability of red, which is just pi r squared out of the whole thing. So pi r squared out of the whole thing. I'm going to divide these two fractions. When I divide fractions, you multiply by the reciprocal of the dividing fraction, which is this one. So I'm going to have 0.5 pi r squared divided by 7.7854 r squared times the reciprocal of this fraction, which is 7.7854 r squared, which is going to cancel totally with this one. And we're going to end up with 0.5 pi r squared over pi r squared. And the pi r squareds are going to cancel, leaving us with 0.5, which is a half. For 14c, the blue region, given that the point is located in the green region, that it's in the blue region, given that it's inside the green region. Now this is the only green and blue part right here. Blue given green is the probability of blue and green, which is right here, out of the probability of green. Blue and green, this little tiny region, which is r squared out of the whole thing. So we have r squared out of the 7.7854 r squared divided by the probability of green. The probability of green is 4r squared out of the 7.7854 r squared. We're dividing these two fractions, so I'm going to multiply the top fraction by the reciprocal of the dividing fraction, which is the bottom fraction. So I have r squared over 7.7854 r squared times 7.7854 r squared divided by 4r squared. These two numbers are totally going to cancel, and we're going to be left with r squared over 4r squared. The r squareds will cancel, and we're going to be left with 1/4. And that's 14c. 14d, the region with 3 colors, given that the point is located in a region with at least 2 colors. The probability that the region has 3 colors, that's red and green and blue, given that it's located in a region with at least 2 colors. So 2 colors, so red and green, or red and blue, or blue and green. The probability of red and green and blue intersecting the red and green, or red and blue, or blue and green. So what is red and green and blue? That's this little region right here, this little quarter circle. What does this region have in common with red and green? Red and green. This region united with this region, red and blue, united with blue and green. So what does this region have in common with all of this, including this part of the square? Well, just this region, just red and green and blue. Just red and green and blue. Red and green and blue out of the probability of red and green united with red and blue united with blue and green, which means all of this, 3/4 of the circle and this little part here. So think of it this way, half a circle and this little square. The probability of red and green and blue, so we're talking about the quarter circle out of the whole region, that's going to be 0.25 pi r squared out of this, 0.25 pi r squared out of the 7.7854 r squared, divided by this whole region, like that. So think of it as half the circle, 0.5 r squared, added to r squared. Okay, so 0.5 pi r squared plus the r squared, divided by the whole region. We're dividing fractions, so I'm going to multiply by the reciprocal of the dividing fraction. So we have 0.25 pi r squared divided by 7.7854 r squared times 7.7854 r squared. These are totally going to cancel. Divided by 0.5 pi r squared plus r squared, which simplifies to that. If you want, you can factor out the r squared like that, and you end up with 0.25, which is a quarter. The 4 comes down here and multiplies the 0.5, which gives you 2 pi plus 4. We end up with, and the r squares totally cancel, so you end up with pi over 2 pi plus 4. That's a little bit complicated. So I'm just going to do the 0.25 pi all over the 0.5 pi plus 1, and that's going to give me 0.305508, and it goes on forever, which is 30.5508%. And that is it for question number 14. Have a good day.